Welcome back, Grade 6. Today we're working on Nelson Math, Chapter 2, Section 1, Exploring Greater Numbers. Before we start with the Grade 6 work, I'd like to take a bit of a review from previous grades. We're going to review with some numbers that, while still great, are not as large as the numbers we're going to be seeing in Chapter 2. So we're going to review a little bit doing it this way. Let's say, for example, I wanted to find out how many seconds there are in 5 days. If we made a plan, we might say, well, let's see how many seconds in 1 minute, how many minutes in 1 hour, how many hours in 1 day, and how many days in 5 days. We could set out a plan and calculate one bit at a time. And that's what I did down here. So we know the following. We know for sure there are 60 seconds in 1 minute. We know for sure there are 60 minutes in 1 hour. Therefore, to find out how many seconds in an hour, we can do 60 times 60. Imagine you have 60 minutes, and inside every minute there's 60 seconds. To find out the total number of seconds in those 60 minutes, or 1 hour, would be 60 times 60, and that is 3,600. So this part that's in red is very important to us because there are 3,600 seconds in 1 hour. We also know there are 24 hours in a day. So in every one of these 24 hours, there would be 3,600 seconds. So to find out how many seconds in a day, we can do 3,600 times 24. So in 1 day, we have 86,400 seconds. But we want to know for 5 days. So if 1 day has 86,400, 5 days would be 5 groups of 86,400, which we can calculate by multiplying 5 times 86,400, which gives us 345,600 seconds in 5 days. And that would be our intro for this section, that we have that many seconds in 5 days. Now let's start to get to the larger numbers. Our goal today is to compare numbers up to 1 million. We're going to be doing a few of these calculations today, so let's read this example. Khaled did some research on the body for his science project. He found some interesting facts. Eyes blink about 900 times an hour. Hearts beat about 72 times a minute. We take about 20,000 breaths a day, and the heart pumps 7,200 liters of blood a day. To show how busy the body is, Khaled wants to estimate how long it takes to do each of these things 1 million times. So just to make a distinction here, it doesn't ask how many times can it do it in 1 million minutes or 1 million hours. It's not asking that. It's asking how long would it take for each of these things to happen 1 million times. So our answer must be in a time. The answer must be in seconds or minutes or hours or days or weeks or months or years. Let's move on. From our information, we can see that eyes blink about 900 times in 1 hour. So let's take a look here. I've written down in this chart the number of hours and the number of blinks in that hour. And I've written down here in 1 hour, we get about 900 blinks. Clearly, that is way less than a million. So we have to increase that, but we want to do it in a controlled way. We want to make sure we know what we're doing. So let's see how many blinks in 10 hours. It makes sense that if in 1 hour there are 900 blinks, then 10 hours, which is 10 times 1 hour, there would be 10 times as many blinks. So that would be 9,000. We're still way too low. Let's try it again. How about 100 hours? So in 100 hours, we can multiply 1 times 100, or we can multiply 900 times 100. That gives us 90,000 blinks in 100 hours. We could have also done 10 times 10 is 100, so 9,000 times 10 is 90,000, but we're still too low. Let's try it again. How about 1,000 hours? And we can do this by multiplying 100 times 10. In other words, 90,000 times 10 is 900,000. Now we're pretty close. we're not that far away. 1,000 hours gives us 900,000 blinks. So we're pretty close, but I think we can get closer. We coincidentally have two numbers here that when you add them come very close to a million. So 900,000 plus 90 is 990,000. So if in 1,000 hours it takes 900,000 blinks, and in 100 hours it's 90,000 blinks, in 1,100 hours we would get about 990,000 blinks. So that's pretty close. So our estimate here could be 1,100 hours is the amount of time it takes for 990,000 blinks. And because that's pretty close to a million, we can leave it at that. To check this, we could look at, or not to check it yet, but to see how many days this is, we can take 1,100 hours, and we know that there are 24 hours in one day. So if we divided 1,100 by 24, we would get 45.8. So about 46 days. So about a month and a half for our eyes to blink about 1 million times. Let's take a look now at the number of heartbeats. Our number of heartbeats has been given to us not in hours, but in minutes. So in this one, this unit distinction is very, very important. If we don't use our units properly, then our data would be way off. So in this case, it's 72 beats in 1 minute, but we want about 1 million. So let's see how close we can get here. We could multiply them both by 10. So for 10 minutes, we'd get 720 beats. For 100 minutes, we would get 7,200 beats. For 1,000 minutes, we'd get 72,000 beats. So you can see we really have to do a lot more here in terms of multiplying. For 10,000 minutes, we would get 720,000 beats. So now we're much, much closer. Let's see how close we can get. Now, because we are much closer, I'm not going to go to 100,000 minutes because that would have given me about 7 million, and that's way too much. So we're going to increase by 1,000 minutes each time. So instead of continuing to add a zero like we did and keep multiplying it rather by adding a zero on the end every time, we're going to now add 1,000. So if 10,000 minutes was 720,000, we could add another 1,000 minutes, and that's 792,000. So we're getting there. We're getting closer. For 12,000 minutes, I added one more 1,000, 864,000. For 13,000 minutes, we added another 1,000 minutes, 936,000. So let's add 1,000 more minutes, and now we're very, very close to a million. We just passed it. So it takes 14,000 minutes to have 1,008,000 beats. That's pretty close. So that would be a very good estimate. However, typically, it's hard for us to gauge, well, how long is 14,000 minutes? Would I be able to count for 14,000 minutes? Could I walk for 14,000 minutes? Could I hold my breath for 14,000 minutes? It's hard to say. So how about we take a little look and see how many hours that is. So 14,000 minutes divided by 60, because there are 60 minutes in 1 hour, that would give us about 233.3 hours. So that's a number of hours. Let's see if we can get it into even more manageable units. If we took 233.3 hours divided by 24, because there are 24 hours in one day, we would get about 9.7 days. So it takes about 10 days for the heart to beat 1 million times. And that's how we're starting our work here with larger numbers, being able to to manipulate them and feel comfortable with this. Enjoy the homework, and I'll see you next time. Have a good day.